Notice in our short-run labor demand curve for an imperfectly competitive firm, we lay out the marginal revenue product as our demand curve. The value of marginal product, however, is going to be higher at every unit of labor except the first. And that's represented as a value of marginal product curve that's higher. Now, this is not to scale, but it's just to show that the valuation that society, consumers, are going to place on the workers' output is greater than the value that the firm actually sees for that output. Why? Because the firm values the output based on marginal revenue, whereas the consumer, society, values it based on the price of the good. So we're going to get this difference between the decision making of the firm and what society sees as optimal. And that difference is going to show up in the imperfectly competitive product markets. Now let's continue on and talk about long-run labor demand. The models we built so far have helped us understand a short-run scenario. That is, a situation where the firm has at least one fixed input. Typically, that's capital, and then adjust their labor to maximize their overall profitability. In the long run, however, both labor and capital are variable. And so the total product for a firm in the long run is a function of capital and labor. Variable capital and labor. This is sometimes referred to as scaling. A company can scale up by adding more machines and workers, or it can scale down by subtracting machines and workers. Like the short-run demand curve, the long-run curve is downward sloping because a wage decline has two simultaneous effects. These two effects are the output effect and the substitution effect. The output effect actually shows up in the short run and the long run. And here's the way to think about it. If wages go down, that lowers the marginal cost of production. You can see that in the diagram here. In this market, we've got the product that the firm is producing, the price of the product on the vertical, and the quantity on the horizontal. A typical firm will have a marginal revenue, which is the price that it sells the good for, and then it'll have an upward sloping marginal cost curve, which tells us that in order to produce more of output, they're going to incur higher marginal costs. This would be the prototypical firm. The firm maximizes profit in its product market by continuing to produce the good so long as the marginal revenue price that it generates is greater than the marginal cost. And that's true to this point here. This firm would choose 40 units of output as its profit maximizing level. Now let's say that this firm sees a wage decrease. In this particular model, that's reflected as lower marginal costs of production. In essence, this marginal cost curve 1 shifts down by the lower wages and becomes marginal cost curve 2. More importantly, you'll notice that now previously unprofitable units, 40 to 70, which would have had a cost before the wage decline greater than the price they could sell the good at, now are profitable because they have a cost that is less than the price that they could sell the good at. So this firm would ramp up in its production from 40 to 70 as a result of the lower marginal costs via the lower wages. We call this an output effect because if the firm is going to ramp up from producing 40 to 70 units from the lower wages, then it's going to need to hire more workers to make that happen. So the output effect of a lower wage is the firm will hire more workers. You can see that effect in our labor market down here. We have the wage rate on the vertical and the quantity of labor on the horizontal. Let's say we start at point A. Say the firm is paying a wage rate of 800 and profit maximizing with 3 units of labor. Well, if the wage goes down, let's say it drops to 600, the firm, as we just saw, ramps up production and hires more workers. And that's a movement from A to B. Thus, this movement from A to B from the lower wage is purely an output effect. They hired an additional worker, 3 to 4 workers, in order to increase the production of output from 40 to 70. In the long run, there can also be an output effect. In the long run, you can have wages go down, which cause lower marginal costs, and that will cause a firm to ramp up their employment of labor. However, in the long run, there is also a substitution effect. In fact, this one can only occur in the long run. Why? Because a substitution effect is essentially substituting one input for another. And that's only possible if all inputs are variable. So you can't have a fixed input if there is going to be a substitution effect. Example, let's say wages decrease. The wage decreases cause firms to substitute capital with relatively cheaper labor. The lower wages mean that firms will want to use labor more than capital. So they may get rid of some machinery and hire some workers. That is reflected in our model at point A to point C. Now, why the difference? Well, because in the long run, you have both effects. In the long run, a wage decrease from 800 to 600 allows a firm to ramp up and hire a lot more workers. From here, it doubles the workers from 3 to 6. Whereas in the short run, that same wage decrease only moved us from A to B. We only added one worker because there was only one effect. So we say that in the long run, the demand for labor is more elastic. When wages go down, firms will hire more workers because, one, there's an output effect. They want to make more stuff now that the costs of production are lower. And two, a substitution effect. Get rid of some of that more expensive capital and substitute it with labor. In the long run, they can do both. This affects, or I should say these effects, you probably are seeing around you, but not with wage decreases. Instead, we've been seeing wage increases for quite some time now. And what has that done? Well, with higher wages, that's raised the marginal costs. The higher marginal costs, say from marginal cost 2 to a higher marginal cost 1, has caused firms to cut output and therefore cut workers. So we would move along our short-run demand curve for labor from B to A. But at the same time, because labor has become more expensive relative to capital, you see a lot of firms getting rid of workers and substituting with machinery. This is a long-run effect because the resources must be variable. And from that standpoint, we move from point C to A, witnessing even more layoffs than we would in the short run. In essence, higher wages are driving companies to produce less product and to substitute away from labor towards capital and decreasing the amount of employment that they engage in. Now let's talk about the wage elasticity of labor demand. In a previous chapter, we discussed the wage elasticity of labor supply. And you're going to see that it's the same formula, but instead of plugging in the percentage change in quantity supplied of labor, we put the percentage change in quantity demanded in the numerator. The denominator is the same, the percentage change in the wage rate. So this is the formula for the elasticity of demand. We always use the midpoint method if we're not given the percentages, and the midpoint method is calculated in this manner. If you don't recall how to do these calculations, it might be worth revisiting that previous video on the elasticity of labor supply. But let's use a labor demand example here. Suppose a firm goes from 5 to 2 employees when the wage rises from $8 to $12? What is the elasticity of demand? Is this an elastic or inelastic response? What if the same increase in wages causes the firm to go from 5 to 4 employees? Inelastic or elastic? Okay, let's practice this. First thing we're going to do is recognize that we don't have percentages in this example here. So we're going to need to use the midpoint method to calculate our percentage numerator, this, and the midpoint method to calculate our percentage denominator, this. It says that the firm goes from 5 to 2 employees when the wage goes from 8 to 12. We know the change in quantity is from 5 to 2. That's -3. So let's go ahead and put -3 there. Then we look for the average of the quantities, which is the sum, 5 plus 2. That's 7 divided by 2. 7 divided by 2 is 3.5. If you do the math, -3 over 3.5 gives you, and we'll round, -0.86. The denominator is the change in wage divided by the sum of wages divided by 2. So the change in wage was 8 to 12, so that's +4. And the midpoint would be 8 plus 12, which is 20 divided by 2, which is 10. And if you do that calculation, you're going to get 0.4. So now we need to take -0.86 and divide it by 0.4. And if you do that, you should get -2.15, approximately. So the elasticity of demand is equal to this. Of course, when we're evaluating whether we have an elastic or inelastic response, we need to use the absolute value. So we get rid of that negative. The absolute value is therefore 2.15. Recall that if you have an absolute value of an elasticity coefficient that is greater than 1, it is an elastic response. So that's what this would be. What if the same increase in wages causes the firm to go from 5 to 4 employees? Well, in this case, the denominator is still going to be 0.4 because it says the same wage change, but the numerator is going to change. If we go from 5 to 4, then this numerator effectively becomes -1 divided by the midpoint. Well, 5 plus 4 is 9 divided by 2 is 4.5. And if you do that calculation, you get 0.22 approximately. Take 0.22 and divide it by 0.4, and you get an elasticity of demand equal to -0.55. Okay. Take the absolute value, which is 0.55. It's less than 1, so we would say that is an inelastic response. So notice that when the wage goes up by 0.4, we see an elastic response initially, going from 5 to 2 employees. Then we see an inelastic response in our second example, going from 5 to 4 employees. In both cases, though, these coefficients are helping us measure the responsiveness of labor demand, firm employment, hiring, as a result of changes in wage. Also note that they're both negative, implying an inverse relationship. It's always going to be the case. When we were looking at the elasticity of supply, we could get a negative, we could get a positive. But with the elasticity of labor demand, almost exclusively we would get a negative. As wages go up, firms will hire less workers. And as wages go down, they'll hire more. Okay, next we'll talk about the wage bill.